Well, first of all, thank you for having me here. I've been to Prague many, many times, always as a tourist. You know, I did the bridge stuff, I did the central stuff, but I've never been to a university in Prague. Really happy of being here, and it's a special evening for the czjug, and I know how difficult it is sometimes to have a special evenings because I rule the Paris czjug. So again, thank you for having me here. As you can see, I'm using the Geekon slides because I'm on a road movie, a road trip to Geekon. So I'm using the Geekon slides. So if you go to Geekon, this is the exact same talk I'll be doing in Geekon. If you don't, well, you have it for free tonight. But you should go to Geekon. It's a nice conference. Okay, so I'm going to talk about CDI. I'm going to focus on on dependency injection. So CDI is a lot of stuff, and I'm going to concentrate in just a small topic. CDI is quite rich and complex sometimes. That's why you don't see many books out there talking about it. It was a difficult spec to come out at the time, a lot of political issues. So I'm just going to take a little bit of it. Type-safe injection, dependency injection. Here I am, my name is Antonio. I'm a freelance software engineer back in Paris. I've written 2 books, Java E5 in French, so if you want to practice your French, that's a good way to start, and Java E6 in English, that you can see up there. And I'm also an expert member on Java E6. I've applied to be expert member on Java E7. I am expert member on Java E7, but it looks like I'm on my own. The spec is not moving. It's a bit weird. The spec lead has gone. I don't know if you followed the news or not. So it's a bit strange, but it will happen hopefully. And yeah, I'm the co-leader of the Paris czjug, so that's also why I love czjugs. Do you know the Java Posse here? Who knows the Java Posse? Okay. Well, if you want to learn French, I do a postcast with my friends about Java, a bit like Java Posse. So if you're fed up of listening to English and if you want to switch to French, les cascodeurs. So that was a bit about me. So I'm going to briefly introduce inversion of control, you know, as a whole. And then I'll dig into CDI, and that's it, really. Just on the dependency, injection side of it. Who knows CDI? Yeah. Who has used CDI? Okay, not many people. Well, not at all. Okay, interesting. So let's start at the beginning. Inversion of control. This term was popularized in '98 by an Italian guy from Sun. He was actually later on the creator of Apache Avalon. So inversion of control is 3 things. It's the control of dependency resolution is given to someone else, but also the control of life cycle and the configuration. So that's what inversion of control is. That's why sometimes you see people saying inversion of control and dependency injection is the same thing, and some people say no, it's not the same thing, it's part of it. So the idea is the control of these 3 things is given to someone else. And the entire idea is to bring loose coupling. So here on your left side, on your left side, you see we can manage our dependency ourselves. I'm going to show you that in a few slides. We can manage our configuration ourselves too, and we can manage the life cycle of the components ourselves. Inversion of control is give these 3 things to someone else. CDI deals with these 2 topics: dependency injection and lifecycle management. The configuration is not in the standard, is not in the spec itself. If you follow what's happening in SIEM, there's actually an extension that gives you configuration, but it's a SIEM extension. Maybe one day it will go into CDI, but at the moment the CDI covers dependency, injection, and lifecycle management. And I'm just going to focus in this talk on dependency in injection. So I've been talking about dependency. What is a dependency? Well, you see at the bottom I have a service, item service, and the role of this service is to create a book. A book is just a POJO. It has two attributes, an ISBN number and a name. Simple. The ISBN can be a bit tricky, so we depend on the ISBN generator. That will give me an ISBN number. So as we can see here, the item service depends on two classes. We do that all the time in Java. How do we do it? Simple. At the top there, you see the item service. It has an attribute, ISBN generator. And as you can see in the constructor there, it creates a new instance of the ISBN generator, and then it uses it to create a book. It delegates the generation of a number and puts it in the ISBN. Easy. That's what we do all day long. What's wrong with that? Not much. Again, I'm not saying that dependency injection is the way to go. I'm just saying the only problem with that is we have strong coupling. If you don't care about strong coupling, the new keyword is fine. Strong coupling, I can't change the implementation. There's the new with the ISBN generator class. That's it, I can't change it. I can't mock it if I need to test it. The life cycle is done by the component. Here it's quite easy. If I go back to the slide, it's easy. The life cycle is new. I create an instance and the garbage collector will get rid of it. But sometimes the life cycle can be complex. I create an instance, I open it, I pull it, I passivate it, activate it, and close it and destroy it. That can be complex. That means I have to do the job. So again, there's nothing wrong with what we saw, but sometimes you might not want this strong coupling. That's when dependency injection arrives. And inversion of control. Give the control to someone else. So dependency injection was a term coined by Martin Fowler, but a few years after inversion of control, that was in 2003 or 4, something like that. And the idea is to decouple the dependency between components. Dependency injection is also called the Hollywood principle. If you want to become a movie star, you go to Hollywood and you go and knock on people's door, you show them how good you are, and they say, yeah, good. But don't call us, I'll call you. That means you will not get the job. But that's the Hollywood principle. So the idea is, item service, don't call me, I'll ask someone else to call you. And this someone else is, as we'll see, an injector. Okay, so let's give you another example here of dependency injection. How can we do it? So in this case, I have an interface number generator. And in one case, it's going to create an ISBN number, which is a 13 digits. And in the other case, it creates an ISSN number, which is 8 digits. How do you choose from one to another if you want to change implementation? Well, dependency injection helps you. And we can do that in several ways. The first one that we know is constructor injection. and setter, you know, injection. They both work the same way anyway. How does this work? I still have my item service. This time I have an attribute which is an interface. And how do I choose the implementation? Well, I don't. I give the control to someone else. How do I do that? In the constructor or in the setter, I'll tell the caller, please pass me an implementation. This implementation, I'll put it in my attribute and then I generate a number. Easy. So the client, when he creates a new instance of the service, passes the implementation it wants. Easy. That's what we do all the time in Java. The construction of the dependency is given to someone else, not to me. And at the bottom here, I'll show you the same method, but with setters. So I create an instance of a class, and I set the implementation I want. Using the new keyword, you know, easy. But sometimes graph dependency can be quite complex. Here I only have one class, but this class could depend on another class that depends on another one and another one. So instead of saying one new, I end up creating a complex graph of objects. How do we deal with that? Well, we have another pattern called a factory. And we're going to say to someone else, please create an instance of this component with all the dependencies created. Even if it's complex, please do it for me. Well, easy. We do that all the time. Here I have an item service factory with two methods. I can either create an ISBN generator service or ISSN. You see, here I use the new keyword. It could be a complex graph, so here I will do the news and the gets and the sets and whatever. And at the end of the day, I return an item service. So the client calls someone else, so the control is inversed, is given to someone else. Say, please give me item service already created. Factories, full of factories in the Java language, and we use that all the time and it works. There's another way of doing that. It's the service locator. That's another pattern. Not a gang of four pattern, a J2EE design pattern. The idea is to get a service somewhere. Please find me the service I want. It should be somewhere, and give it to me. The perfect example is JNDI. I look up for something in the JNDI. It's there. I take it. I use it. So again, that's inverting the control. I give the control of finding an already created service to someone else, JNDI, for example. So here I say, hey, look for a service that it's called like that and give it to me. It's already built in, etc., etc. And it works well because we use it all the time. So using the new keyword or a factory or a locator works fine. It's just a bit of work and we have to do it ourselves. Here is easy, but it could be much more complex than that. And because we are lazy, and because maybe someone can do it better than ourselves, we tend to give the control to something else. And we've been doing that for many, many years. We give the control to an injector. Injector is also known as a container or a provider. Okay? So the idea is someone else, an injector, provides to a client So you know another Java class. A component with the dependencies. So we give the control to someone else. Instead of us writing factories and news and locators, we give that to someone else. And that's what we've been doing since '99. We've been using frameworks. Apache Avalon was the first one. It's in italic because it's dead. It doesn't exist anymore. Another famous one is Spring. Pico also is a famous one. Sim arrived not many years ago, and Google Juice. Who here uses Spring? Okay. Sim? Okay, not many Sim, okay. Google Juice? Okay. So, you know, Spring, the infamous Spring. So we've been doing that. You know, we've been telling Spring, please, can you look after our dependencies? Well, I'm going to talk about a new one, context and dependency injection. So CDI is much more than that, but I'm going to concentrate on the dependency injector part of it. I always like to give a bit of history. Believe it or not, Java EE is 12 years old now. The first release was in '99. It was called 1.2. Don't look for 1.1, don't look for 1.0, never existed. Don't know why, but here we are, you know, 12 years of specification. With good things and bad things. We all remember the entity beans CMPs. Who worked with entity beans CMPs here in the crowd? Hey, only one guy? Well, with me it's two. So the platform had, you know, some problems, let's say it like that. So in the meantime, in the open source world, we had that. We had Avalon, which was the first dependency injector framework built out of Sun. So Sun was working in a server, and the guy took the code out and put it in open source. Pico container and Spring arrived more or less in the same time in 2003. Sim arrived in 2006. And closer to us, Google Juice. I couldn't find a logo of Google Juice. Don't know if these guys have a logo. Resource injection arrived in Java EE 5, so that was, you know, quite late. Dependency injection arrived in 2009. So we had been, you know, experience of 10 years with dependency injection frameworks. Now Java EE 6 has its own, and it's called CDI. So in EE 6, it wasn't really dependency injection, it was resource injection. So you could inject container resources, EJBs, entity managers, data sources, JMS factories, to certain components, not all. Mostly EJBs, some on the servlets. And to inject that, we had plenty of annotations. At resource, at persistent context, at EJB, at web service ref. And you could not inject a POJO, which wasn't a resource of your app server, of your container. So that's what was happening in EE5. In EE6 is different. Now we have dependency injection. We can still inject resource, but we can inject nearly everything now. And for that we have two specifications. I'm going to talk about, electricity. Whew. I'm going to talk about just later on, but it's a separate spec. So it's a spec for the entire platform. Okay, it's not just for the EJBs, it's not just for servlets, it's separate specs. So in EE5, that's what we could do, you know, mostly inject CJBs into EJBs, EJBs into servlets. We could also inject resources. Now in Java EE6 we can nearly inject everything everywhere. Servlets can inject POJOs, POJOs can inject POJOs, you know. Of course, you cannot inject a servlet into a POJO. You cannot inject a REST service into a POJO because they are HTTP related. But you can nearly inject everything everywhere. And to do that, we have two specs. DI, dependency injection for Java. It's also known as @inject. That is the JSR 330. It's a funny one. I'm not going to go into the entire story of how this spec is born, but it's a funny one because if you go to the JCP website and download it, you will get a Javadoc with 5 HTML pages and not much into it. @inject is 5 annotations. You have the Javadoc of the annotation and a few lines of what it could do. The semantic is on CDI. So really you have to see, and I'm not going to go too much into politics and everything, but DI was just, here is the shelf, you know, here is 5 annotations, supported by Spring, supported by Juice, supported by everybody. But we are not saying how it should work. So @inject in Spring works differently than @inject in Google Juice, that works differently than @inject in Java EE. Because the semantic, how should it work? It's in CDI, so CDI lives on top of DI. It's a separate spec, JSR 299, a different package. It brings semantic to the DI spec and it gives you much, much more. We're going to see a subset of it, but it gives you much more than DI. Okay, so let's take an example now, a bit of code. Here you can see that there is a servlet here that get injected an EJB. And here I have a REST service that can do the same. They use the same notation, the @inject. Good. And you know why? Now you can inject a POJO. A servlet gets a reference from a POJO web service. The EJB could have done the same. Using the @inject. And the EJB uses an entity. I didn't put an @inject there because an entity has a different life cycle. Basically, all the components here are what we call a managed bean. They have a very simple life cycle. Post-construct, pre-destroy. In all these components, you can do something before they get created, and you can do something before they get destroyed. The life cycle of an entity is completely different. Pre-persist, post-persist. Pre-update, post-update. Pre-select, post-select. Pre-remove, post-remove. I've got one extra. That's why you can't use an @inject here. You could, but it will not work the way you want. So don't do it. And you can see here I didn't use an @inject to get my entity manager. I still need to use a persistent context. And I'll explain you why. But basically, all these guys use an @inject. Cool. Let's focus on this bit of code there, on, you know, the bottom part. Here is my servlet. As you can see, it's a 3.0 servlet because I don't need web XML anymore. Hoo-ha! I need a web servlet, annotation. And to get my reference of the ISBN generator, I just use @inject. And somewhere along, I can use it. And you can see my ISBN generator here. Well, I've got a servlet, up there, just a normal servlet. A POJO that doesn't extend anything, doesn't implement anything, is not annotated, it's just a POJO. And here I have an injection point. So here, thanks to @inject, I'm saying, please give me a reference to this POJO. And that's it. I don't have to use the new keyword, I don't have to use a factory. That's really it? Yes, it is. I have no class, no interface, nothing special. I just need a container, and I will show you later on which ones. But, I need a container. This container is my injector. He's the guy who's going to call me. I'm giving the control to him. So I need a container, a provider, one injector, CDI, of course, and a magic file, a beans XML file that you can leave completely empty. It has to be in your class path, either in the meta-env or web-env, if it's a web app or not. But it has to be there because we need to tell CDI, please, can you do the work for me? So that's just a markup file saying, CDI, in this app, there's beans. Please, can you discover them for me? And inject them for me? So that's what triggers. If you don't put this file, it will not work. Just leave it empty, and it will work. So that's the only thing you need. No XML. Yes. Let's go back to this code. Okay, so here I inject a reference of a POJO. Fine. This code is exactly the same as this code. By default, if you don't write it down, CDI will write it down on your back. Every POJO has a default qualifier, and every injection point has a default qualifier. The code is exactly the same. You don't have to write it down, but CDIs, the considers, if you don't write anything, it's the default. The default what? The default qualifier. Qualifiers are names. This is the name by default. But you can give it another name. Hey, this would work. You are giving a name to a bean and to an injection point. This is called a qualifier. And what's this beast? Well, it's just an empty annotation with this magic word here. This is a qualifier. Now I'm going to explain you what is it useful for. Let's go back to our code. Same thing here. I have the same guys, the EJB, everybody is here. And I'm going backwards and I'm saying, by the way, this is an interface. And I have two implementation. The ISBN generator that will create a 13 digits number, and the ISSN generator that will create me an 8 digits number. I give that to CDI and I say, voila. And he goes, what should I do with that? It's ambiguous. This guy is saying, please give me a reference of a bean that implements this. And these guys say, oh, and by the way, I want the same. Yeah, but which one? So at deployment time, not at runtime. That's the good thing with CDI. CDI is really type safe in a way that you know either at compile time that it's not going to work or at deployment time. So if you deploy that, CDI will fail and say the dependency is ambiguous. Which implementation should I give to this guy and which implementation should I give to this guy? Please tell me. How? Using qualifiers. I'm saying, hey, I'm giving you a name here. It could be X, it could be Y. I'm giving it an explicit name because it's explicit. I'm saying you are called 13 digits and you are called 8 digits. Cool. And by the way, could you inject me the 13 digits one? And the REST service, he wants the 8 digits one. It's not ambiguous anymore. That's what a qualifier is useful to. Let's see a bit of code.
Yeah. Ask something?
Oops. Yep.
It's kind of, let's say, compile time dependency. It's possible to somehow say this is equal time dependency and inject these two beans from some kind of, let's say, system property or something like it, based on it.
No, but I will show you later on alternatives. Depending on the environment, you can switch. This is hard-coded, and I'm going to show you. This is code. But in some cases, you might want to externalize that to a bit of XML, and I'm going to show that later on. So how does it work? You know, as I said, I write two qualifiers. What's that? Just an empty notation. So really, you know, it's just to give it a name. Make it as explicit as you can, but it's a name. I could have called that X and Y. Okay, first step. Second step. Here I have my ISBN generator that implements an interface. And I give it the qualifier. I'm giving it a name. Hey, by the way, you are the 13-digit guy. And I'm doing the same thing for the ISSN. You are the 8 digits one. Okay. Remember later on I said, if you don't have anything here, it's default. That's the default name. But here I'm specifying a name. Same thing for the injection point. The servlet is saying, please give me the implementation of this interface that is called 13 digits. Please give me the 8 digits one. Strong typing, no strings. If in my IDE I change the name of this class, hopefully if it's a good one, it will change it here. If you change the class to 2 digits and you don't change it here, compile time, compile error. Strong typing. Yeah?
Sorry, can I ask you, what's the difference between writing at and writing?
Sorry, I don't understand.
You are specifically saying that in this generator there will be ISSN generator. So what I get by using the annotation, if I can use directly new and the generator.
Yep.
Because it's
You bring loose coupling. Here,
the 13 digits you specify directly with this implementation of the 13 digits anyways.
yep, you have here, you say, I'm explicitly giving you a name. Okay? And here I'm saying, I'm explicitly asking for that name. But do you see that you have strong typing, there's no strings. But you have loose coupling. Here, there's nowhere that you're saying, I want the ISBN generator or the ISSN. If tomorrow I change this name to X, my code will work. Because here, I don't care about the implementation. I just care about this name. That's how you get loose coupling. It's strongly typed. I have no XML. If I don't have the name right, I will have a compile error.
Sorry, but if you change the name on the class itself, then it will...
If you change here, doesn't matter.
It's just a different name, you know, on the different place. But still
Yeah.
Okay.
We are bringing it. That's what the loose coupling is. The loose coupling is, I don't care about the name
But it's
of
the
the...
name in the same file, on the same place almost. It's just a different name.
I will show you other nice examples later on. So that's why CDI is much more about strong typing, loose coupling, strong typing, loose coupling. You will hear that plenty of times. I'm using a CDI in a project, and these qualifiers we have more and more and more and more. So it looks like we are going from XML hell, where the Spring application context file is huge, to a qualifier hell. We are creating more and more and more of those empty notations just to give a name, just to put a name somewhere else. Well, there's a trick you can do is use enumeration. When you see that you have 13 digits, 8 digits, 3 digits, 7, 16, blah, blah, blah. When you have a lot, instead of creating a lot of qualifiers, you can use enumerations. This is how it will work. Again, at the top you have a qualifier. I give it another name, number of digits. It has an enumeration here, 2, 8, 10, 13, and I could pack, a number of enumerations. How would I use it? Same way I've used it before. I'm taking my class, giving it a name with an enum, and in the injection point, I do the same. So here at the @inject, I do number of digits, digit 8. So when you see that you have a lot of those empty annotations, that's a nice trick you can use. Until now, I've been showing you code with the @inject based on fields. But you can do also constructor and setup. So this is what I've been showing you. The servlet uses an injection point in the attributes. So here I have @inject with a qualifier, and here I just have an @inject of an EJB. So that's what I've been showing you. But you can also have that. Leave the fields and put an injection point in the constructor. So in the constructor, I need a number generator with a name and an EJB. Or I can put that in the setter. Again, here I don't have the @inject, and I can use the @inject on the setter methods with, as you can see here, a qualifier. It's really a matter of taste. You can, it doesn't change. Either you put in one place or on the other one. It's true that in the constructor and in the setter, you can have a bit of Java code, so you can put business logic there. You can't do that in a field. But just let's step forward a little bit. We are in a managed environment. We are not doing the new, we are not doing the set. Someone else is doing it. Someone else is the injector, the container. So there's certain rules. And the rule number 1 for constructor injection is you can only have one injection point. There's only one constructor that can have the @inject. Why? Because the container needs to know which one. He's going to create an instance. You are not telling him, please do a new on this constructor. It's the container that is doing it, so it needs to know which constructor should I call. So that's the difference. Have you seen any XML so far? No. Yes. We don't have XMLs anymore. Well, we still can have a little bit with alternatives. One question here was, the qualifier stuff is cool. You know, the servlet can have the 13 digits and the REST service can have the 8 digits. It's at compile time, you know, it's at deployment. But what if I want to change implementations? What if I want to use a mock in a test environment? Well, one way, well, not one way, the only way of doing it is using alternatives. That's the only time we use XML in the bins XML file. So how does it work? Here I'm saying, in a test environment, when you inject a reference of the 13 digits, please don't do so. Please use an alternative. So how do you do that? Pretty simple. You say, hey, this is my mock generator, which also implements the same interface. It's an alternative to the 13 digits. Cool. And I can even do, it's an alternative to both, 13 digits and 8 digits. So I can do things like that. The client doesn't change. He still does @inject 13 digits. So the client code doesn't change. The only thing that changes is a bit of XML. And here, if you come from the Spring world or Pico world, it's a bit weird. Because what we expect is, servlets, please, don't take the 13 digits, take the mock. So in this servlet, I want to inject not this one, but this one. Here is different. It's saying, I'm enabling, this is just to say, I'm enabling an alternative. Alternatives are disabled by default. So here I'm saying, I'm enabling the mock generator. And that's it. How will it work? Well, when my servlet says, please inject me a reference of the 13 digits, these guys say, oh, alternatives are enabled. You want to inject the 13 digits, but with this code, I'm telling you that there's an alternative to the 13 digits. And the alternative, it's me. So you see, it's a bit different from the Spring approach. And something with CDI is you can end up having a lot of those things. I'm an alternative to this and that in a scope request, in a scope, session scope, etc., etc. So you can start having a lot of those qualifiers on your bean. With CDI, you can have stereotypes. I'm saying, I'm packing all these qualifiers in a stereotype. I give it a name. And now I'm saying, hey, you are my mock. What is my mock? My mock is an alternative to 13 digits and 8 digits. Type safe, loose coupling, blah, 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 but you really need an intelligent IDE. Because here, it's difficult to see that when you do a @inject 13 digits, you get a mock. So I don't know how the Eclipse guys are going to deal with that. but it's getting complex. And I could even go further. I could have a stereotype of a stereotype. Loose coupling is good, but sometimes you get a bit lost. So stereotypes, we've been using them in UML. This is an interface. That's a stereotype. Now you can do that in your code. And I quite like it because you can give roles to your classes. This is a DAO, this is a service, this is a model, this is a controller, this is a facade. So I quite like the idea. And in fact, in CDI, there's one built-in stereotype, which is called model, from the MVC pattern. A model is a replacement of JSF managed bean. So instead of having managed beans now, you can just change it and put at model. It's clearer. It gives a glossary to the team. This is a model, this is a factory, this is a service, this is a DAO. So I quite like the idea of stereotypes. It gets confusing when you start to have stereotypes of stereotypes of stereotypes. So we only inject beans. So far I've only, injected beans. Well, no, we can go further. We have producers. They gonna produce something to inject somewhere. And this something could be really anything. Because remember that CDI arrived in 2009 and Java was created in 95. So the only way to inject a bean of the JDK is to use that. Okay? The beans, the classes of the JDK are not injectable. With producers, you can produce beans to be injectable, the one of the JDK, but you can use other stuff. Strings, booleans, integers. So how would that work? Here I have another class. It's not my service anymore, okay? It's called a prefix generator. And I have one method which is called getISBN prefix. And I have another one called getISSN prefix. And that will return a string. You can't inject a string. Well, now you can. Because you use the @producers. What you were saying is, this method is producing a string that I can inject somewhere into a string. Cool. How does this work? Well, easy. I'm saying inject a string called 13 digits. What's nice here is 13 digits is in a bean, but it could be in a string, it could be in an integer, and this is answering your question. 13 digits, it's a name. I can put this name wherever I want. Here I made it tricky. It's on a bean and it's in a string. Strong typing. CDI, what will CDI inject in the string? A string. It has the same name, but CDI knows that because it's a string, it's going to inject a string. If it was an integer, it will inject an integer. If it was a boolean, it will inject a boolean. And if it's a bean, it injects a bean. So with the same name, you can inject different things because it's strongly typed. CDI knows that for the same name, it has a string, an integer, a bean. You can choose. So that answers your question a little bit. It makes it even harder. Again, we need good IDEs. I don't use Eclipse. I don't know where Eclipse is in CDI. I use IntelliJ IDE, best IDE in the planet. And IntelliJ IDE helps me a lot, but it could help me a bit more. Here, how do I know that it's going to call get ISBN prefix method? Tricky. How does this guy know that it's that? I need a very clever IDE for that. But we have been struggling with application context XML files of Spring for 8 years. The IDEs are still messing around. So this is Java class. This is code. So I suppose an IDE deals better with code than with text. So I would hope that in the future the IDEs will help me even more. But here it's difficult. How can I jump from this to the method I was? Loose coupling, but you see, loose coupling brings difficult. As Yoda used to say, big responsibilities. No, big. Oh, what was Yoda saying again? with big power. Yeah, with great power brings big responsibilities. God, I should write that down. Producers help you to inject stuff, strings, but also, as I said, JDK classes. If you want to inject a date, you can't unless you use producers. But CDI, because it integrates with Java EE, lets you inject the transaction automatically, the logged in principle, and does some nice thing with bin validation. Again, remember that the CDI had to face major political issues. The 1.0 got out a bit late, but it got out. It will improve on the 1.1 in Java EE 7, hopefully. So at the moment, built in, you only get that. So how can I have a persistence context, an entity manager, classes that are part of the JDK using producers? I give you an example. As I said, you can't inject an entity manager. You still need to use the persistence context. How can you do it with the CDI in a type-safe way, blah, blah, blah? You create a class, and you say, inject me an entity manager, easy, in a persistence context, like we used to do. Here we have a string, because it's like that. That's a JPA. And we say, but I want to expose these beans, so it's injectable. Okay, produces then. This class produces an entity manager. And I give it a name. Oh, sorry. Qualifier. So I give it a name. So now I'm somewhere and I'm saying, please inject the bookstore database. The bookstore database, it's here. It's an entity manager going to this persistent unit. So now you can inject a persistence context. You have that in a separate class, and now you can use @inject. And you can have then several databases, and you can use alternatives. In a test environment, the bookstore database is a MySQL database with a different persistent name. Another example is the faces context. Well, yeah, sure. Write a class, produce the faces context so it can be injected by somewhere else. So if you understood that, now I'm going to give you another funny example. JMS. As I said, we can't inject a resource. we still have to use the resource. So if we want to be able to inject it, how do we do? Produce it. Easy. So here I have a method that produces a connection, and I give it a name. That's what we've been doing on the previous slides. Here I have a method that produces a session. So this session could be, injected somewhere. But look at that. Here I'm saying, to create a session, I need a connection. Which connection? But this one. And it has been created. That's cool. So here, when I call this method, I have a connection that is created. So, how do I use that? You see this name here, the session and the connection? How do I use that? I'm somewhere, I inject a session, a JMS session, and when I create a message, I know the session was injected because it was produced by someone else, and the session was created by the connection. So it's a bit tricky, but I quite like it. And can you see here? Leave the sandwich, please. No, take it. That was a joke. So here it can be a bit tricky. In this code, I do not create a connection because it has already been created. And not by this guy, but by the guy who was called here. So and you can have several levels of indirections. Again, you need a good IDE to help you. But can you see how it works? I'm not just in this slide, I'm not just doing a new and saying, I give you a connection. No, I'm giving you a connection that is already created. So I can produce something much more complex than just, an entity, a string, or a boolean. I can produce a bean that has been created, or, different methods. So that can be tricky. Tricky to debug and follow. Yep. No. You'll have alternatives to these producers. Because they get a name, and you can give an alternative name. It's a different beast from the Spring approach. It's not, please, can you give me an alternative to this class on this object? No. I'm just enabling an alternative. It's a bit different. And to be honest, I get lost sometimes. Let's face it. But like I used to get lost with Spring, sometimes it can be tricky. It's like, and because we all use Maven, we have different Maven profiles with different bins XML. So if you're on test, you do that, and if you're on production, you do this, and you have this alternative and not this one. So it can be a bit messy. And can I use all that from a JSF page? Because I've been talking a lot of beans. Yes, you can. You just have to name your bean or your producer. So the @named is an annotation, just gives a name, really, a name that's going to be used in expression language. So, perfect example here. I have my ISBN generator. I said I name it. By default, it's the name of the class, in camel case. I am in my page and I do ISBN generator, so this name, dot the name of the method. That's what we do with manage bins. Cool. That works. And if you give it an explicit name, you can just change the name. But you can go a little bit further. You can say, I don't want to name my bean. I don't want this bean to be exposed in my page. I just want one method of this bean to be exposed. This method produces a string. It produces a string, so this string will be injectable somewhere. And I'm saying it's named, so it should be injectable in a JSF page. By default, it's the name. So here, again, I need a very clever IDE, because here, I don't give the name of the class. And because it's a name, I can give whatever name I want. So on the previous slide, here I give the name of the method, so maybe my IDE can help me. But here I give it another name. And that will print the string that is produced by this method. Again, can be a bit tricky. And the name has to be unique, of course. So it can be a bit tricky. Well, I've been talking a lot about CDI, but where can you use that? Of course, it comes for free in Java EE 6 and the web profile. So if you use JBoss 6, Glassfish 3, WebSphere 8 soon. But I actually managed to bootstrap the CDI in several environments. It's not standard. So what I did in my blog is use Weld, which is an implementation of CDI. And I do a lot of hacking and configuration, but it really worked. And in production, I'm using it with Tomcat. So all the examples that I've showed you, well, except the servlets and the EJBs, because you need a special container. But all the examples that I've showed you with the producers, alternative, etc., works with Java SE. So you can have your main class, it will work. Tomcat 6.7, JT 6.7. It doesn't work on the application client container of Java EE, which is a shame. And it doesn't work on Spring 3. So I've started saying Spring 3 implements DI. Yes, it implements @inject, @named, but it doesn't implement the @producers or alternatives and so on. Tomorrow at GeekCon I'll talk to the Spring guys. I don't know if they'll change in 3.1, but I couldn't manage to make this work with Spring. One thing I managed is in a big application I did a replace all @autowired with @inject, and it worked. And in few thousand classes. So if you want to have one less dependency in Spring, you can do that in Spring 3. It's a specification standard, so there's several implementations. Weld, which is the reference. Open Web Beans from Apache, Candy from Cowshow. And I've just focused on the DI part of it, but CDI is much, much richer than that. It's becoming a central part of the platform. One very interesting topic is the extensions. So the Java EE platform will be, hopefully, extendable with CDI extensions. So what makes unique? Well, it's a standard. People say that Spring is a de facto standard. Yep, it's de facto. This is a standard. It's type safe, as we've seen, and it's extensible thanks to the extension framework that I didn't show you. And what about the future? Well, the future is a bit unknown for Java EE 7 at the moment, but CDI 1.1 is on the way. The specification has been approved. And one thing that really is interesting is in CDI 1.1 we will have a standard embedded mode. So it will be standard to have CDI in Tomcat, in Jetty, in Java SE. At the moment, you need a bit of hacking, a little bit of configuration with funny classes, but it will be standard. And if you want to know more, well, there's my fantastic book that you can buy. It covers nearly everything except CDI. Because when I wrote it, CDI was in great turmoil, so I didn't write about it. But the weld documentation is fantastic. Don't read the specification, it's a spec, so it's, you know, read the weld documentation, it's really good. That's it.